Hi everyone. Let's consider this example. This is a DFA. Okay. In this DFA, we have total 5 different states and the input alphabet sigma is A comma B. Now I want to minimize this DFA. Okay. So minimization means maybe I can reduce 2 or more states into one single different state and got some different transition diagram. Got the minimization. So for the minimization purpose, what you will do here is first you will draw the transition table. So drawing transition table is very much easy by using the transition diagram. So the two different input alphabet is A comma B, and we have 5 different states: Q0 initial state, then Q1, Q2, Q3 and Q4, and Q4 is our final state. Let's draw the line so that it will make clear. Now Q0 on seeing small a will go to Q1, on seeing small b will go to Q2. Q1 state on seeing input A will go to Q1 itself, and on B it will go to Q3 state. On Q2 state will on input small a will go to the state Q1, and on input will go to the Q2 itself. Okay. Similarly, Q3 on small a will go to Q3 on small a will go to Q1, and Q3 on small b we will go to Q4. So Q4 is the final state. Now the last state is Q4. Q4 on small a will go to Q1, and Q4 on small b will go to Q2. So our transition table is, in this transition table there are 5 different states, 2 input alphabets, and I have depicted each moves for each row in this transition table. Okay. Now the equivalent concept is used after you draw the transition table. So what is equivalent set concept? First you will differentiate the final state from non-final state. Okay, so zero equivalent always start with zero equivalent, and zero equivalent contains one is final state as together and non-final state as together. So what are the non-final states here? The non-final states are Q0, Q1, Q2, Q3. So the non-final state is Q0, Q1, Q2 and Q3. And what are the final state? There is only one final state, which is Q4. Okay, this is zero equivalent set. After constructing zero equivalent set, we will move to one equivalent set. And one equivalent set is formed or is achieved using zero equivalent set. Okay, so first let's take this non-final state Q0, Q1, Q2, Q3. First we will take these two as a together, Q0, Q1. So Q0 and Q1. On small a it will go to the same state Q1, and on small b it will go to Q2 and Q3. Q2 and Q3 is present in the same equivalent, same particular row. So Q2 and Q3 will present in the same box. It will not present in the different box. So definitely Q0 and Q1 will come together in the one equivalent also. Now consider Q0 and Q2. Q0 and Q2. Q0 and Q2 on small a will go to Q1, which is in the same box, and Q0 and Q2 on small b will go to Q2, which is also in the same box. So definitely Q0 and Q2 will come together in the one equivalent set. Now consider Q0 and Q3. Q0 and Q3 on small a will go to Q1, which is present in same box, and on a small b it will go to Q2 and Q4, but Q4 is present in different box. So whenever the two, if you compare the two different states, and it will go to two different boxes, one box is let's say non-final and other box is final, it will go to two different boxes. That means this will not come together. So I have taken Q3 as a different box and Q4 as a different box. So in the one equivalent, you will get Q0, Q1, Q2 as together. Q3 is separated now, and Q4 is already a final state which is separated. Now find two equivalent set. So two equivalent set is achieved from one equivalent. One equivalent is achieved from zero equivalent. So always the present equivalent set which you wanted to construct is achieved from the previous equivalent set. Now let's compare Q0 and Q1 again, because here we get three different boxes, but in the previous we get only two boxes. So we will compare starting from Q0 and Q1. Q0 and Q1 on a small a will go to Q1 itself, which is in the same box, and on a small b it will go to Q2 and Q3. If you observe carefully, Q2 is present in this box and Q3 is present in different box. That means Q0 is now separated from Q1. Now compare Q0 and Q2. Q0 and Q2. Q0 and Q2 on a small a will go to Q1, same state, same box, and on a small b it will go to Q2, which is also same box. So definitely Q0 and Q2 will come together, and Q1 is in different box, Q3 is in different box, and Q4 is in different box. Okay. You can also compare Q1 and Q3. Q4 is always in a different box because it is a final state. Q1 and Q3. Let's say Q1 and Q3. Same state, Q1, same box, and then Q3 and Q4. Q3 and Q4 different. That means they are also separated from each other. Now construct three equivalent set. So this procedure is repeated until the two equivalent sets are different from each other. If I get the three equivalent equal to two equivalent, then I will stop this procedure. Okay. So Q0, Q2. Compare this Q0 and Q2. Q0 and Q2. On a small a, go to Q1, same state, and on a small b, go to Q2. It is also same state. Okay. The box on particular move is same. If it is different, then we will separate them. But if it is same, Q1 and Q2 is present in this box, Q1 is present in this box. That means in this particular three equivalent, Q0, Q2 will come again together. Q1 is separated, Q3 is separated, and Q4 is separated. Okay. So two equivalent set and three equivalent set are equal. So I have to stop this procedure. And finally, how many boxes present here? There are four different boxes present. So the final minimal DFA will contain four different states. The four different states will be respectively as Q0, Q2 is one state, then Q1 as second state, Q3 as third state, and Q4 as fourth state. So if I draw the transition diagram, Q0, Q2, and what is the initial state? Here in this transition table, the initial state Q0. So definitely it is Q0, Q2 is the initial state, then Q1, Q4 and Q3. Okay, and Q4 is the final state because Q4 here is final state. And how to take the transition move? Again, you will consider the transition table. Q0 and Q2. These two are together. So Q0 and Q2 on small a will go to Q1. On small a, it will go to Q1. And on small b, it will go to Q2. On small b, it will go to Q2. Q2 means same. So here I will take a loop. On small b, it will go to Q2. Similarly, Q1 on small a will go to Q1 itself, and on small b it will go to Q3. On small b it will go to Q3. Similarly, Q3 state on small a will go to Q1, on small a will go to Q1, and on small b it will go to Q4. It will go to Q4. Okay. Now final state Q4 on small a will go to Q1, and on small b it will go to Q2, and on small b it will go to Q2. So this is the final and minimal deterministic finite automata of this particular transition diagram. So here the language whatever be, but you will apply this procedure to achieve the final minimal DFA. Okay. So in the next video we will see one more example to understand the minimization of DFA.